Hello there, Mr. Sutton bringing you a lesson on piecewise functions. In this one, we're going to learn how to evaluate, graph, and write these functions, and there's a lot of real-life applications for these, including a tax code. We'll begin this lesson with a piecewise function in action. Let's say the fictional state of Taxachusetts taxes citizens differently depending on what their income is. So let's say if you make less than $10,000, you don't owe anything. There's nothing to take, right? If you make between $10,000 and $30,000, they're going to take a fifth of whatever you made. And if you make over $30,000, you have to give the government half of what you made, decreased by $9,000. So they'll give you $9,000 back. So we want to know how much you'll owe if you made the following amounts: negative $5,000, $12,000, and $80,000. And we're going to build a piecewise function based on the rules that they gave us up here. So for piecewise functions, we typically have a big bracket here to let people know that all of this stuff is part of the same function. Now let's make a rule for each of these three cases. So the first case, under 10,000, we owe nothing, so that is a constant function of 0. And then, so that's if x is less than 10. If x is between 10,000 and 30,000, let's say including those numbers, then we have to owe a fifth of what we made. So that'll be like 1/5 times x, or x over 5. And then finally, if x is greater than 30, we have to do 1/2 times x, decreased by 9, so minus 9. And this is a piecewise function for telling us how much we owe in taxes. So just to officially define it, this function we created here is called a piecewise function. It's made of different pieces. It's got different rules for different inputs, different intervals. And you might wonder, why we're using this weird kind of function. But if you think about it, life is kind of like this. Depending on what the world is throwing at you, you have to do different things. You're not going to use the same response, the same output for every single input that you get. So that's really what piecewise functions are all about, being flexible about the response. So let's go ahead now and plug in these 5 numbers, or the 3 numbers here. The key on all these is to first figure out which rule you have to use and then apply that rule to the input. So for example, if we're doing f of negative 5, if you lost $5,000 using our real life example here, we would have to use the first case because negative 5 is less than 10. So that's the first rule. The first rule just returns 0 no matter what. So f of negative 5 then is 0. We're saying you don't owe any taxes. Let's take a look at our second input now of 12. 12 falls in the second rule because it's between 10 and 30. So we have to apply the second case here. That's going to be 1/5 times the input of 12. And that's just going to be 12 divided by 5, or $2.4 thousand in taxes. Finally, we'll apply the 80,000 here. So if you made 80,000, you're bigger than 30, so you have to apply the last rule for your taxes. That's going to be 1/2 times 80 minus 9. Half of 80 is 40, minus 9 is $31,000 in taxes. Just to make sure you've gotten the hang of this, pause the video and try negative 3 and 7 in this piecewise function here. All right, let's see how that went for you. Our first one, f of negative 3. Negative 3 is less than negative 2, so we have to use the first rule. That'll be 10 times negative 3 plus 8. So that's going to be negative 30 plus 8, or negative 22. Next, doing f of 7. 7 is between negative 2 and 10, so we have to use rule number 2. That's going to be 7 squared minus 12, or 49 minus 12, which gives us 37. For our last example, we'll see how we could graph a piecewise function, and we'll just do a small one here that has 2 lines in it. So just getting the general lay of the land here, we have this line, 3x minus 5, and that's going to be what our function looks like until we get to the x value of 3. Once we get to 3, we're going to turn into this other line, negative 2x plus 16. Now, to graph a line, we need 2 points. So one helpful point might be the ending point for our first rule. So what I like to do is I like to plug my boundary values into both functions, and that gives me the endpoint for the first function and the starting point for the second branch. So using our first rule here, plugging 3 into that, that's 3 times 3 minus 5. That's 9 minus 5, or 4. This gives us the point 3 comma 4. That is the point where this branch ends and the other one begins. Now, is it going to be an open or solid dot? We have to be careful about this. Looking at the rule here, this is the rule. This first case is the rule if x is less than or equal to 3. Since it's got the equals in this, we're going to make this a solid dot at 3 comma 4. So we're going over 3, up 4, right there. And now we need one more dot in order to graph this first line. And there's a lot of ways you can get this. You could just plug in any x value less than 3, and that'll give you another point. But let's be fancy. This is in mx plus b form, so we can get the slope-intercept, or that you can get the y-intercept here. So you can use slope, y-intercept, plug in a value. Here the y-intercept is -5. So we'll put a dot at 0 comma -5 down here. And we'll just draw a line through those. Now careful, because your line has an end point right here at 3. So we're only going to have an arrow going in one direction to the left down here. Next, let's get the starting point for our second rule. So we're going to plug 3 into this second function to do that. So this will be -2 times 3 plus 16. That's -6 plus 16, or 10. So we have the point of 3 comma 10. Now we have to be careful because you're not allowed to have two solid dots at the same x value, at least if the two solid dots are different y values. Because remember, that would fail the vertical line test and we would no longer have a function. Since we already used up our solid dot on this first one, this other one better be an open dot. But if you look at the rules here, this function applies, this rule applies only if x is greater than 3, not equal to 3. So there's no equals here. That tells us, yeah, we're going to have an open dot there. So at 3 comma 10, that would be up here. My y values are going by 2's. I've got an open dot to tell me where my second branch starts. And now we can't use the y-intercept of 16 because that isn't part of this function's interval here. The y-intercept is where x equals 0, and this function only works if x is greater than 3. So we're going to have to use something else like the slope of -2 in order to get another point. So starting at the start point here, we're going to go down 2 and over 1, and then we can draw a line through those. For this next problem, we're going to take a look at a step function. A step function is just a piecewise function where you have constants on each interval. So for this piecewise function, we're actually going to create a piecewise function to describe it. To start this process, we're going to start on the far left, and we're just going to write the constant y value for each of the steps. So we'll just do one step at a time here. So I write out my little piecewise function setup. I've got 3 intervals, so I'm going to need 3 rules to describe those. My first rule is just going to return the constant value 24. And then to go with each of my rules, I need to write an inequality that describes that step. Got to be careful with the open versus solid dots when you do your inequalities. So this rule is going from 0 to 50, including 0, but not including 50. And we're going to use standard inequality notation here. So we'll use 0 less than or equal to x less than 50. For some reason, they never use interval notation in piecewise functions. All right, pause the video and see if you can get the next 2 rules on your own, and we'll bring it back together. All right, let's see how you did. So you've got, what's the y value here? Well, these grid lines are going by 4s, it looks like. So we've got halfway, that's going to be a y value of 10, and that's happening between 50 and 120. So we've got 50 less than or equal to x less than 120. And then for the last one, we have the y value, that looks to be 20. From, we've got 120 to infinity, so we'll just write x greater than or equal to 120. That's it for this lesson. Until next time, this is Mr. Sutton, peacing out.